In this example, we want to show the KCL. So at any certain node, the amount of current that enter the node equal the current that leaves the node, or I equal to I1 plus I2. And or summation of the currents is equal to 0, because we can assume the current enter the node positive, the currents leaves the node are negative, so their summation should be 0. So here we have a circuit 1000 ohm in series with the voltage source. It doesn't really matter the value. The value is 11.78, and then we have here I1 and here we have I2. So we want to show this, that this I is equal to I1 plus I2. Now, this is the circuit that we have here. This is the 1000 ohm, this is the 220 ohm, and this is the 1000 ohm. So as we mentioned before, to measure the current, we need to open the circuit. So let's see the main current, which is the current I, the main current. So I will need to open the circuit, disconnect the voltage supply from the top resistance, and let's see how much current is that, because we have to have the ammeter in series with it. So if we come here and connect the leads, so here this is the positive and here is the negative lead. So we see here the current is around 10 milliamps. So the main current I here is 10 milliamp. Now let's connect back the voltage supply to the resistance, and let's disconnect I will do here, I will disconnect the bottom of the resistance here and connect the ammeter in series with the 220 ohm. So if you do that, I will come here and I will remove the resistance from here. I put it here from the common ground. Okay, and now I will come and measure this current at the bottom. So I will connect here. So the current is around 8.2 milliamps, 8.2, 8.3 milliamps. Return it back. So as you notice here, the voltage measurement was much easier because we don't need to disconnect anything. It has to be in parallel. But the current here, we have every time to disconnect the circuit and connect the ammeter. So let's see here how much the current there. So it's around 1.7. So we have 10 milliamps, 8.3 here, and 1.7 here, which make the KCL.